Hi everyone, today I will show you a trick that will make you a real expert in Math Olympiad questions, and that is the QM, AM, GM, HM inequality. But let's first prove them for two variables. So let's A and B be positive real numbers. That means that A minus B squared is greater than or equal to 0, since a square is always positive. Now this means that A squared plus B squared is greater than or equal to 2AB. And now we will add A squared plus B squared on both sides of this inequality. This will give that 2A squared plus 2B squared is greater than or equal to A squared plus 2AB plus B squared. Let's now divide the two inequalities by 4. Then A squared plus B squared over 2 is greater than or equal than A plus B squared over 4. And now we can take the square root on both sides, since the square root is an increasing function. This means that the root of A squared plus B squared over 2 is greater than or equal than A plus B over 2. And that is our first result, which is the QM-AM inequality. And let's now do the AM-GM inequality. We know that the square root of A minus the square root of B squared is also positive. Now this means that A plus B is greater than or equal than 2 times the square root of AB. And if we now divide both sides by 2, then we get that A plus B over 2 is greater than or equal to the square root of AB. And this is very rapidly our second result. AM is greater than or equal to GM. For the third result, we just apply 2 for the two numbers 1 over A and 1 over B. So 1 over A plus 1 over B divided by 2 is greater than or equal to the square root of, and we substituted 1 over A for A and 1 over B for B, so that gives the square root of 1 over A times 1 over B. Now if we take the inverse on both sides, then the inequality will change, and that will give us that 2 over 1 over A plus 1 over B is less than or equal to the square root of AB. And that gives us our third result, the GM-HM inequality. But all these inequalities also hold for n variables. For n positive variables, the inequality becomes the following. The root of all the squares divided by n is greater than or equal to just the normal average of the n numbers, is greater than or equal to the nth root of the product of all the n variables, is greater than or equal to n divided by 1 over x1 to 1 over xn. Now don't be intimidated by all this notation. We will plug in some variables to make it easier. So let's say that x1, x2, x3 is equal to just one variable x, 2x, 3x, for some x a positive real number. This makes the inequalities, the first one, the square root of x squared plus 4x squared plus 9x squared over 3 is greater than or equal to the average, which is x plus 2x plus 3x over 3. That is greater than or equal to the third root of the product, which will be 6x cubed, and that is greater than or equal to 3 over 1 over x plus 1 over 2x plus 1 over 3x. And this is true for all x positive numbers. Now let's plug in maybe two variables. Let's say that x1 is equal to a over b and x2 is equal to b over a, with b a greater than 0. Now this gives that the square root of a squared over b squared plus b squared over a squared over 2 is greater than or equal to a over b plus b over a over 2 is greater than or equal to the square root of a over b times b over a, but this is just 1, of course, and that is greater than or equal to 2 over b over a plus a over b. So you see that you can be creative with the choices, such that, for example, one of these means just becomes an integer, and the other ones stay valid for b and a positive integers. So let's now solve the two problems. This is the first problem. Let a, b, c be positive real numbers, such that a plus b plus c plus 2 is equal to abc. And then we have to prove that 1 plus ab times 1 plus bc times 1 plus ca is bigger than 125. Now, from this first statement, we would want to make an estimate of how big ABC can be. And we will do this by using AMGM on A, B, C, and 2. So on these 4 variables. So that gives us that A plus B plus C plus 2 over 4 is bigger than or equal to the fourth root of A times B times C times 2. But now notice that this is just ABC over 4. So this gives us that if we bring the 4 to that side and then we raise everything to the 4th power, that A times B times C to the 4th is bigger than or equal to 4 to the 4th times 2 times A times B times C. But this means that we can divide both sides by ABC, such that ABC cubed is bigger than or equal to 4 to the 4th times 2, which is 2 to the 9th. And now we get that ABC, if we take the third root, is bigger than or equal to 2 to the 3rd, which is 8. So we know that ABC is bigger than or equal to 8. Let's work with that. Now we will use a clever trick. I will rewrite 1 plus AB as 1 plus AB over 4 plus AB over 4, and this 4 times. Now we have 5 terms, and we see that this is 5 cubed, so maybe this will help. We will now use the AIME inequality, AIME, on these 5 terms. This gives us that the sum divided by 5, which will just be 1 plus AB over 5, is greater than or equal to the 5th root of the product of all these terms, which is AB to the 4th over 4 to the 4th. I hope you're staying with me. But now we can do the same for 1 plus BC and 1 plus CA. So this gives us that 1 plus BC over 5 is greater than or equal to the 5th root of BC to the 4th over 4 to the 4th, and 1 plus CA over 5 is bigger than or equal to the 5th root of CA to the 4th over 4 to the 4th. But now we can multiply all these inequalities. We multiply all these sides and all these sides. And this will give us that 1 plus AB times 1 plus BC times 1 plus CA is greater than or equal to, then we can multiply all the 5s to the other side of the equation, and we get 125 times a big product, which is the 5th root of the product of all these terms, which will be 4 to the 12th, and on top we will have AB times BC times CA to the 4th. But now, of course, this is equal to 125 times the 5th root of, and this will get us A to the 8th, B to the 8th, C to the 8th, which will be ABC to the 8th over 4 to the 12th. But now we know that ABC is greater than or equal to 8. So this will be greater than or equal to 125 times the fifth root of 8 to the 8th over 4 to the 12th, which is 1. So this will be 125. And we proved the inequality. Let's now go to problem 2. The second problem states that x, y, and z are both greater than or equal to 0 and are real numbers, such that x plus y plus z is equal to 1. We then have to prove that xy plus yz plus zx minus 2xyz is less than or equal to 7 over 27. So first, let me call this f of x, y, z, such that the notation is more easy. Let me calculate 1 over 2 minus x times 1 over 2 minus y times 1 over 2 minus z. This is equal to 1 over 8 minus 1 over 4 times x plus y plus z plus a half times xy, yz, and zx and then minus x, y, z. But now we can use that this is given to be 1. So this will be 1 over 8 minus 1 over 4, which is minus 1 over 8. Plus, and I will write 1/2 times xy plus y z plus zx minus 2x y z. But now notice that this last expression is just equal to f of x, y, z. So we can express the left-hand side of the inequality by the things we have established. We can say that f of x, y, z is equal to this product, 1/2 minus x times 1/2 minus y times 1/2 minus z plus 1 over 8. But then we have to multiply by 2. So here's 2, and this will be 1 over 4. And now we have a really nice expression to work with for the rest of the proof. Now we have established the following equality. But observe the following. X plus y plus z is equal to 1. Now this means that only one of x, y, and z can be less than 1/2. Otherwise, the sum would be greater than 1. So, case 1 is that exactly 1 of x, y, z is greater than 1/2. Now what will happen in this case? What will happen is that one of these three factors will be negative, and the other two will be positive, which means that this whole product will be negative. So then we can say that the left-hand side, which was f of xyz, is less than or equal to a negative number plus 1 over 4, which will be less than or equal to 1 over 4 in this case. But this is just 7 over 28, which is less than 7 over 27. So in this case, we have proven the inequality. Now in case 2, we can assume that x is less than 1/2, y is less than 1/2, and z is less than 1/2. But now that means that these three factors are all positive. And now we can use the AIME inequality. So AIME gives us that 1/2 minus x plus 1/2 minus y plus 1/2 minus z over 3. This is AIME for these three numbers, is greater than or equal to the third root of their product. Times 1/2 minus z. But notice that this is equal to 3 over 2 minus the sum of x, y, and z, which is equal to 1 minus 1 over 3. So we get that this part, 1/2 minus x times 1/2 minus y times 1/2 minus z is less than or equal to this to the power of 3, which is 1 over 2 divided by 3 to the power of 3, which is equal to 1 over 6 cubed. Now that means that f of xyz is less than or equal to 2 times this, which is less than or equal to this, so 1 over 6 cubed, and that's plus 1 over 4. Now let's calculate this expression. That is exactly 1 over 3 times 36 plus 1 over 4, which is 1 over 3 times 36 plus 27 over 3 times 36, which is 28 over 3 times 36, which is, if we divide both sides by 4, is 7 over 27. And I hope this video showed some useful tricks that you can use in mathematical Olympiad problems. And don't forget to like and subscribe.